Hey again, AP Chemistry. So this is going to be part 2 of quick check number 2. So I'm going to be running through calorimetry calculations, and you're going to do more of this in class, but we have to remember this equation of Q is equal to MC delta T. Okay? So how much energy does it take to heat 150 grams of aluminum metal from 25 degrees Celsius to 150 degrees Celsius? The specific heat of aluminum is 0.900 joules per grams degree Celsius. So if it's asking for heat, it's asking for the letter Q from this equation. Q represents heat, and heat is a form of energy, okay, as opposed to work is another form of energy, but heat has to do with changes in temperature, okay? So I have 150 grams of aluminum. That's going to be my mass. So I'm going to put M is equal to 150 grams, okay, of aluminum. And I want to change its temperature from 25 degrees Celsius to 150 degrees Celsius. That's having to do with my delta T. Delta T is T final minus T initial. And it's saying it wants to go from 25 degrees Celsius to 150 degrees Celsius. So if it's going from 25 degrees Celsius, that's my initial temperature. And if it's going to 150 degrees Celsius, that's my final temperature. And it's supposed to be final minus initial, so equals 150 degrees Celsius minus 25 degrees Celsius. The change in temperature from 25 to 150 is 125 degrees Celsius. And then C is my specific heat capacity, or specific heat. My specific heat of aluminum was said to be 0.900 joules per grams degrees Celsius. So now I have my M, I have my C, and I have my delta T. I just have to combine all of them to solve for Q. Q equals MC delta T. M, we said, was 150 grams. C is 0.900 joules per grams degrees Celsius. And then my delta T is 125 degrees Celsius. I want to show you how our units cancel out here. Grams on the top, grams on the bottom, they cancel out. Celsius on top, Celsius on the bottom, they both cancel out. I'm left with joules. If I do this math correctly, I should get 16,875 joules that were added, or it's positive, right? It's a positive number. When delta T is positive, basically I'm adding energy. If delta T is negative, I'm removing energy. Okay, so keep that in mind. And then I want to do another question. This one's going to be huge. This one has to do with getting a final temperature. So this is one way of doing it. There are other ways of doing it, but this is just one way. So it says I have 375 joules of energy. That's my Q. Is added to 25 milliliters of water at 20 degrees Celsius. What is the final temperature of the water? The specific heat of water is 4.1 joules per grams degrees Celsius. So again, we're going to be using Q equals MC delta T. Okay, I already have my Q. It's 375 joules. My M, I have to figure that out. I have 25 milliliters of water. Something that we have to remember, and you will see a lot of, is that the density of water is 1 gram per milliliter. That means for every 1 milliliter, there is 1 gram. For every 1 gram, there is 1 milliliter. So if I have 25 milliliters of water, I will have 25 grams of water, right? So that's something to keep in mind, right? They'll give you the density. Typically, they like to tell you that the density of a solution, the density of something is 1. If they tell you the density is 1, then you assume your milliliters is equal to your grams. They do that a lot, right? So if the density is equal to 1, you assume your milliliters is equal to grams, all right? They told you the specific heat capacity of this liquid water is 4.18 joules per grams degrees Celsius, and they did not give you a delta T, right? They gave you an initial temperature, but they didn't give you the change in temperature. I'm going to hold off on using the 20 degrees Celsius right now because I could solve for delta T given these 3 out of my 4 variables. So Q is equal to MC delta T. Q is 375 joules equals 25 grams, 4.18 joules per gram degrees Celsius, delta T. Okay. And so, if I solve for that, right, if I want to solve for delta T, I have to bring M and C over to the Q. So just as an aside note, Q over MC is equal to delta T. This is rearranging this equation. Some of us struggle with algebra and rearranging equations because if I have more than one letters or if I'm not using X and Y, we need to become more comfortable with that. So if I want to rearrange and solve for delta T, I'll get 375 joules over 25 grams, 4.18 joules per gram degrees Celsius. That's going to be equal to delta T. If I do this math correctly and I'm able to cancel out my units, I'm going to be left with Celsius. I have 1 over Celsius in the denominator that ends up being Celsius. I end up with 1 over degrees Celsius. That's just going to be equal to degrees Celsius. Just showing you with our units here. If I do this math correctly, delta T is going to be equal to 3.59 degrees Celsius. Now that's my change in temperature. It's not my final temperature. And we have another equation. Delta T is equal to T final minus T initial. And I could actually just plug that in. Now notice my delta T is positive here. Delta T is positive. That means I'm probably going to increase in temperature. So upon inspection, I could see that my change in temperature is positive 3.59. So my final temperature could be 23.59. But I want to prove that mathematically. So my delta T is 3.59 degrees Celsius. My T final, I don't know, but my T initial is 20 degrees Celsius. I'm plugging these in. If I want to solve for T final, I will add 20 degrees Celsius to both sides. And I will get T final is equal to 23.59 degrees Celsius. So this was an important quick check because this quick check went over how to use Q equals MC delta T. I could either use it to solve for Q or I could use it to solve for delta T. Or if I want, I could solve for M or C given any of the other variables. This is just an equation where I could plug and chug and solve for one another. The trick thing here is solving for delta T. So I would look back at this video if you ever need a little bit of extra practice or help in trying to solve for delta T.